Good afternoon. Welcome to our class. In today's class, we'll discuss Poisson distribution. So yesterday we talked about binomial distribution. I hope you remember you've gone through the videos. In case if you missed the yesterday class, because yesterday I believe very less people were there. So if you are not seen, I really request that please go through that. So all these are continuation of our discussion on probability. So in probability, when we talk about probability is based on random experiment. And when we talk about random experiment is an experiment where we know the outcomes and we are measuring the possibility of the outcome. So in the case of random experiment, whenever you see repeated trials, we use for binomial distribution. In the case of binomial distribution, the formula for binomial distribution is NCR P to the power R Q to the power N minus R, where P is called the probability of success and Q is called the probability of failure. Okay, and when we talk about binomial distribution, in case of binomial distribution, we have limited number of trials, and under each trial, we have two possible outcome, either success or either failure, and each trial is independent of the previous trial, and the next trial will be independent of the previous trial. Okay, and we have limited number of trials, so and every trial will give you two mutually exclusive outcomes, either it is success or either it's failure. Okay, so that was basically a binomial distribution. So the limiting case of binomial distribution is Poisson distribution. So when we talk about Poisson distribution, the probability under the Poisson distribution, this was the probability function under binomial distribution. So Poisson distribution is the limiting case of binomial distribution where the probability of success is very small, where the n is very large. So in under such kind of scenario, when the number of trials conducted are very large, okay, and the probability of success is very small, okay, the trials are independent, the variables are discrete. So under all that scenario, the resultant outcome what we get, we'll call that as a Poisson distribution. We'll call that as a Poisson distribution. So when we talk about Poisson distribution, so under Poisson distribution, the probability of success, that is we follow the formula e to the power minus m into m to the power r by r factorial. Okay, where m is called the mean, where m is the mean, where m is the mean, where the formula of mean is n into p. Okay, so basically what happens now, when we talk about binomial distribution, when we talk about binomial distribution, in the case of binomial distribution is biparametric distribution. Binomial distribution is biparametric distribution, which has two parameters, which were n and p. Okay, but when we talk about Poisson distribution is basically it is uniparametric distribution. It is uniparametric distribution. It is uniparametric distribution when we talk about Poisson distribution. So here in the case of Poisson distribution, we don't have separate formula. Okay, we don't have separate formula for n and p and all. So in the case of uniparametric distribution, like Poisson distribution, your mean and variance, okay, both are equal to n into p. In the case of Poisson distribution, while the standard deviation, when we talk about the standard deviation that will be equal to under root of n into p. This is the Poisson distribution. So remember this formula. Now this is the formula of probability distribution. When we talk about Poisson distribution, this is the formula. This is the formula of probability distribution in the case of Poisson distribution. Now here, what is m? M is the mean, where the m, here what is m? M is the mean. Many book they use the formula e to the power minus lambda into lambda to the power by r factorial, and you know that m or mean is equal to n into p. You know that very well. So what is E here? Now the question arises, if you don't know what is E, E stands for Euler number. So E basically it's a irrational number. I'll show you. So like when we talk about E, what is basically E? It's the inverse of natural logarithm. So when you see E is called Euler number. E is called Euler number. It is basically it's an irrational number. I believe you all are mathematics students. You understand what a irrational number. So real number are of two types. They are rational number or they are irrational number. So rational numbers, when we talk about rational numbers, you can express them in P by Q form. While those numbers which you cannot express in P by Q form, those numbers we call as irrational number. So those numbers, when it expressed in the form of decimal, they are non-recurring, they are non-terminating decimals. They are called irrational number. So E is basically irrational number. You will get the value of E when you follow the formula limit of x tends to infinity 1 plus 1 by x to the power x. So this will give you a constant like pi, which we called as E. So it's the inverse of log E, natural logarithm. The inverse of that is E. In MS Excel or in scientific calculator, if you press shift and then ln means log E, so you'll get exp. Exp means exp. When we say exp is the log E. Exp1 is equal to this is the value of E. This is your E. It's a constant. Okay, so normally I think you directly use scientific calculator or in your mobile calculator, you can directly use E there. Okay, so normally only thing we sure about one thing that in Excel or scientific calculator and all. So that normally when we write the formula like e to the power RT, like continuous compounding formula is future value is equal to present value into e to the power RT. So or in here also Poisson distribution, the formula is e to the power minus m into m to the power r by r factorial. So here power sign and all in Excel or in scientific calculator, if you do that, they will take in brackets. So e to the power minus m. So it would do like this. Excel, if you have to do, you do like this. In Excel, E means exp. Many time in many mobile calculator also you will find exp. So please be clear about this part. Clear, right? Anyone any doubt? Now let's do one problem to make you understand the concept of problems of Poisson distribution. Suppose your problem is like this, that in a company manufacturing twice, in a company manufacturing twice, it is found that one in 500 is defective. Find the probability. Find the probability of their. Find the probability of there will be at most two defective. Okay, a sample of 2000 units. Clear everyone? So you can see this question. So to solve this question, I can find the mean. Mean is equal to n into p. So n is sample of 2000. N is 2000. P 1 in 500 is defective. P is 1 by 500. It is found that 1 in 500 is defective. So here the mean is equal to 4. Clear everyone? So find the probability that they will be at most two defective. The probability that they will be at most two defective. Find the probability that there will be at most two defective. That will be probability of zero defective plus one defective plus two defective. That will be at most two defective. So this would be P0 means e to the power minus m into 4 to the power 0 by 0 factorial plus e to the power minus 4 into 4 to the power 1 by 1 factorial plus e to the power minus 4 into 4 to the power 2 by 2 factorial. So e to the power minus 4 I can take common. If I take common, I left with 1 plus 4 plus 16 by 2. So this is e to the power minus 4 into 1 plus 4 plus 8. So this is e to the power minus 4. This is 13. 13 e to the power minus 4. So if you want, you can calculate 13 e to the power minus 4 means 13 e to the power 4. You are getting right. 13 e to the power 4. E is 2.71828. If you want, you can take it. You can solve it in case you can remember the values also. E value 2.71828. So if I do directly, how will I do directly with Excel or with calculator? I hope you can do like this with calculator. There will not be much difference. Let me to show you directly. If you do directly, then you can see 13 into e to the power minus 4, right? 13 into e to the power minus 4, right? Yeah. And then if you see this, 13 divided by, if you show 2.71828 to the power 4, you can see in 6 digit you are getting different. Otherwise, both mean same. So the answer is 0.2381. Clear, everyone? So your answer is 0.2381. Anyone doubt? Clear, everyone? Anyone, any doubt? So you can use this formula, guys. So this e to the power minus m power r by r factorial. With that, you can solve any problem. Okay. Now, if you see the next question, that if x is the Poisson variable, x is the Poisson variable such that p of x is equal to 2 is equal to 9 into p x equal to 4 plus 90 into p into x is equal to 6. Find the mean and the variance of x. Find the mean and the variance of x. Solve this. So x is equal to 2 mean and variance. Let the mean and variance, right? Poisson distribution is same only. Let the mean and the variance. Let the mean and the variance of a Poisson distribution is equal to m. Okay, so if I write in the equation e to the power minus m into m to the power r by r factorial is equal to 9 into e to the power minus m into m to the power 4 by r factorial means 4 factorial plus 90 into e to the power minus m into m to the power 6 divided by 6 factorial. Here everyone. So what I can do, I can take e to the power minus m into m to the power r by 2 common. I can do that e to the power minus m into m square divided by 2. In bracket I left with 9 m square. 4 factorial is 24. 24 divided by 2 is 12 plus, okay, 9 also I can take common. Yeah, leave that. This is 90 into m to the power 4. 6 factorial is 720, right? 720 divided by 2, this would be 360. So you can see this, I can cancel this and this. So I can get 1 is equal to, I can take 9, I can take 9m square by 12 common. So I'll get 1 plus 10m square by 30. Clear? So means 1 by 3. 30 or 40, right? Here I took 12 common. Yeah. So I'll get 12. So this is 4 by 3 m square. 9 by 12 is 3 by 4, right? I can write 4 by 3 m square. 1 plus m square by 3. So you can solve this. 4 by 3 m square is equal to 3 plus m square by 3. 4 is equal to 3m square plus m to the power 4. I can write this as m to the power 4 plus 3m square minus 4 is equal to 0. So m to the power 4 plus 4m square minus m square minus 4 equal to 0. So here I can take m square common. So m square plus 4 minus 1 m square plus 4 equal to 0. M square minus 1 into m square plus 4 is equal to 0. So the value, so m square is equal to 1 and m square equal to minus 4. So m value will be equal to 1. Mean cannot be negative, so plus 1. And here mean you get imaginary number. Here you are getting m is equal to 2i. So the 2i I'll not consider. So here you mean and variance both are equal to 1. Clear everyone? Clear everyone? Anyone have any doubt? Ask me question, guys, if you have any question. I hope this is clear with everyone. Now, next thing we'll discuss is the fitting of Poisson distribution. Next thing we'll discuss is the fitting of Poisson distribution. The next thing we'll discuss is the fitting of Poisson distribution. Okay, so when we talk about the data, suppose if we get the data in the form of class interval and frequency, suppose this is my x, this is my f. Okay, so fitting of Poisson distribution. So I'll find f into x. This is 0, this is 59, this is 28, this is 09, this is 04. Sum of fx. So 9, 9, 18, 18 plus 8, 26, 30, 3 carry, 5, 3, 8. Sum of fx is 100, and the sum of f we do. This is 12, 12 plus 4, 16, 19, 20, 2 carry, 5, 7, 9, 10, 10, 200. Sum of f is 200. So the mean here is sum of fx by sum of f. The mean is 100 by 200 by 2. The mean is 1 by 2. Mean here is 1 by 2 or 0.5. The variance also, you know that, right? Both same thing. Standard deviation will be, if somebody asks me what is the standard deviation, that would be square root of 0.5, correct? So we know the mean. So mean is 0.5 here. So you know the formula of mean, right? N into P. So mean is N into P, that is 1 by 2. N is 4 here, right? 4 into P is 1 by 2. P is equal to 1 by 8. Anyway, here P does not make any significance. So once you get this n into p mean is 0.5. So what I can do here, the first thing what you need to do, the same thing we did in binomial distribution also. We need to find a probability distribution. Remember, right? So the first thing what we need to do, we need to find the probability distribution. So for the probability distribution, we're going to use a formula e to the power minus m. M is 0.5 into m to the power r means 0 divide by 0 factorial. This is e to the power minus 0.5. Clear everyone? The next one would be e to the power minus 0.5 into 0.5 to the power 1 by 1 factorial. This would be 0.5 e to the power minus 0.5. Clear? The next one that would be divide by 2 factorial. So e to the power minus 0.5 into 0.5 to the power 2 by 2 factorial. So 0.5 to the power 2 divide by 2 factorial into e to the power minus 0.5. So 0.5 square is 0.25. 0.25 by 2 is 0.125. 0.125 e to the power minus 0.5. Then this is 0.5 cubed by 6 into e to the power minus 0.5. 0.5 cube is 0.125 by 6. 0.5 cube by 6. 0.5 cube by 6. 0.020833. 0.020833 into e to the power minus 0.5. Then this is 0.5 to the power 4 by 4 factorial means 24 e to the power minus 0.5. So 0.5 to the power 4 divided by 4 factorial means 24. So that is 0.002604. 0.002604 e to the power minus 0.5. So how will I able to find this value e to the power minus point? So how will I able to find this value? Suppose e to the power minus 0.5 e to the power minus 0.5. This is e to the power minus e to the power minus 0.5. This is nothing but 1 by e to the power 0.5. This is nothing but 1 by square root of e. Okay, that is nothing but 1 by square root of 2.71828. You can see that will give you approximately this value. So again, I'm trying to teach you how you can solve the given problem without using E also. In case in exam, if scientific calculator is not allowed, so the question comes how you can solve this question. So now I think with calculator, either simple or scientific, you can easily find the square root of 2.71828. So 1 by that value. 1 by that value. So 1 by that value, 1 divided by square root of 2.71828 0.606531 or e to the power minus 0.5. You can see both give you the same answer. So it doesn't matter you're using e function or not, it doesn't matter, you will get the same answer only. Correct, right? Everyone understanding? 6065.060653. Clear everyone? Anyone have any doubt? Done, right? Everyone got this value 0.06, 0.606531. So you get this 0.606531, 0.606531. So then 0.5 means divide by 2. 0.303265. You're getting it right. 0.125 means 1 by 8 divided by 8. So divided by 8, divide this by 8. 1 by 8. You know the right table of 8. 0.606531. Can you divide it by 8? Yes, right. 0.0756, 46, 46, 5, 46, 60, 46, 46 means 46 means 5. 5 means 65, 65 means 8, 13, 13 means 1, 51, 51 means 6. Okay, so you're getting it right. Now here you can use calculator, you can find the value 0.02083 into 0.606531. You can find the value. You can use calculator 0.2088, 0.020833. Okay, and that you can multiply with 0.606. So this into 0.012636, point 0.12636. So then next one is 0.0062604. 0.00260. 0.0015. 0.00158. So here what I'll do, I'll find px into n. Find px into n. Px into n. N is 200. 200 into 200 into p into x. 200 into 0.606531. 121. Approximately 121. Then next one would be half of that. 61. Approximately you can say next one it would be 61. Then 0.075. Then 1/8 of this value. 1/8 of this value. 121 divided by 8. 15, approximately 15. And then 0.012636. This into 200. 3, approximately 3. And then this into 200. 0.31, approximately 0. The total, if you do the total of this, you'll get around 200. So this is how we do the fitting with respect to the Poisson distribution. So only thing we need to calculate is the mean, and that mean we calculated by this formula, that sum of fx by sum of f. Once we get the value of mean, we can find the probability distribution. And once we find the probability distribution, we can find the values, expected values, expected frequency values. Clear, everyone? Anyone, any doubt? You can see this question number 5. You can try this question number 5. You can see same like what we have done so far in Poisson distribution. 10 marks question came. Fitting of data in the Poisson distribution. One of the very important topic, guys. So from the binomial and Poisson distribution. So this is one of the question number 5 kind of question is very important. You can write down this question number 5, and this is your homework. You can do this question as your homework. Send me the answer. Try this question number 5, everyone. This is your homework. Clear, everyone? Anyone have any doubt? So this much we'll do today. We'll continue our discussion tomorrow. Anyone, any doubt? Thank you, everyone. I'll see you all tomorrow.